Hey guys, hope y'all's Monday morning is off to a great start. Go ahead and get out your notes and turn to 10.7. While you're doing that, I'm going to go get the correct notes. So get out 10.7, and if you write big, you might need some extra scratch paper. So get some notes and some scratch paper, pencil, calculator, and I'll be back in a second. All right, sorry about that. Okay, so in 10.7, we are talking about special segments in a circle. So I need you to make sure that you don't have your headphones in, that you're paying attention, because this lesson can get a little bit tricky. So we all need to have our Monday morning game face on and ready to go, okay? All right, so special segments. In 10.7, we're learning that if two chords intersect in a circle, then the products of their length are equal. So that means A times B, circle A, times B, is equal to C times D. You cannot add them and they will equal each other. That is not the case. They have to be multiplied. If you add, they will not work. Okay, so in order to find x and lengths of the chords inside the circles, when they're intersecting, you have to set their products of the chord equal. So for example, this chord is made up of 3 and 8. So, and 6 and x is the other chord. So you see, you have to take AB, which is 6, times BC, which is x, set it equal to 3 times 8. So when you multiply those together and divide by 6, you get that x is equal to 4. If you would have added 8 and 3, that gives you 11. 6 plus 4 is not 11. So your answer would be incorrect because x is actually 4. So main idea is that you have to multiply them. You have to multiply them, not add them. Okay? So, in number 1, you have to multiply the parts of the chords. So I'm going to circle what has to be multiplied, and I'm going to, let's say, triangle the other two. So 2 has to be multiplied by x, and 3 has to be multiplied by 6. So 2 times x equals 3 times 6. So 2x is equal to 18, and then divide both sides by 2, and you get that x is equal to 9. So that is the answer for number 1. Okay, that was easy. Good. Warming up. Hold on one second. Okay. Number 2, sorry for all the distractions. Number 2, multiply x times x. Now, on this one, you have to be very careful because 10 is the length of the radius, which means the other radius has to be 10. And this is 2. So that makes the portion from here to here 8. Okay, let me say that again. They gave you the radius. The radius is 10. So that makes this other radius 10. And if that's 2, this has to be 8. So really, the sum of this length is 18. So we have to multiply x, and then you have to multiply 2 and 18. So x times x equals 2 times 18. X times x is x squared. 18 times 2 is 36. To cancel out the square, you take the square root of both sides, and x is equal to 6. Okay, that one was a little different because they gave us the radius. Number 3, they don't give us the radius. They give us each individual section. So we have to multiply 6 times x and 8 times 8. So 6 times x is equal to 8 times 8. So that becomes 6x equals 64. Divide both sides by 6. You get x is equal to 10.7. So if you want to check yourself, you can. I mean, you solved for x, so plugging it back in will just give you the same thing. This checking ourselves will come, it'll be useful a little bit later. Okay, I'm going to start using scratch paper on number 4. So if you're going to use scratch paper, here's the time. Okay, because on number 4, we have to multiply x times x plus 7 and 3 times 6. So that's going to look like this. This is number 4. X times x plus 7 equals 3 times 6. So now this is just an Algebra 1 problem. You have to solve the equation for x. But when you distribute this, you get x squared plus 7x equals 18. 3 times 6. So anytime you see an x squared, I need you to automatically think in your head, I have to factor. Unless it was a scenario where it's just x squared equals something. If there's multiple parts and it looks like you might have to factor, you probably do. So the first step is we want to set this equal to 0. We need to get 18 to the other side. So right now 18 is positive. We move it by subtracting. So you get x squared plus 7x minus 18 equals 0. So our a starts with a 1, so we can use the easy method. So your answer is going to look something like this. You're going to have x equals 0. So you need to think of two numbers that multiply to give you negative 18, that add to give you 7. 9 and 2 are the first two numbers that come to mind to me. They have to be positive when I add them, so that means the 2 has to be negative. So your answers are going to be x plus 9 and x minus 2. However, you have to completely solve for x, which means you have to set x plus 9 equal to 0 and x minus 2 equal to 0. So now we have two different solutions. When I subtract 9 to solve completely for x, I get negative 9. And when I add 2 to both sides, I get x equals 2. So I have two solutions. It's this one or this one. Well, if you try to plug negative 9 back into here, x can't be negative 9. This section can't be negative 9. That doesn't make sense. So negative 9 is out, and our answer is 2. Another way to check this, if you don't like that solution, if you don't like just thinking that doesn't make sense and you want a concrete way, plug it back into here and see which one equals 3 times 6. Because 2 times 2 plus 7 equals 18. 2 plus 7 is 9. 9 times 2 is 18. Okay, so your solution, your answer for number 4 is x equals 2. Now, number 5 is its own problem. It's different because all 4 of these are radii. And I could take you the long way around this, like I did earlier, and work it out doing this. However, this is a long problem, and then I realized, well, if all of those are radii, right, they all have to be the same thing, then x has to just be 3. And that works when they're all 4 radii. Notice here, those aren't radii, so it doesn't work. It works here because they're all radii. So 3 plus 2 is 5. So if all of those are 5, then 5 times 5 equals 5 times 5. Okay, 6 is like the one up here, which I'm glad we have another one so we can kind of talk through it. So they gave you that the radius is 7. So that means from here to here also has to be 7. And if 2's already taken, then from here to here has to be 5. Also, if this side is x right here, then this has to be x. So number 6, you set it up like this. X times x equals, x times x equals 2 times 5 plus 7. You add them together if they're in the same section of the chord. You only multiply them when they're different. So 7 plus 5 is 12. So you could also say x squared equals 12, this is 12, times 2, which is 24. Take the square root of both sides. X should be equal to 4.9. I'm going to double check. Yes, so x is equal to 4.9. Okay, the next two look doable, so I want you to take a couple minutes right now and try 7 and 8 on your own. Okay, so let's look at what happened on 7 and 8. Okay, so you're going to multiply 2x times 3x, and then 6 times 5. So 2 times 3 is 6. X times x is x squared. 6 times 5 is 30. Divide both sides by 6, you get 5. Take the square root, and you get 2.2. Same thing on number 8. 3x times x, and then 8 times 6. So it becomes 3x squared equals 48. Divide both sides by 3. Take the square root of 16. You get x is equal to 4. All right. So that was just what happens when they intersect inside the circle. Now we're going to talk about what happens when they intersect outside a circle. Okay, so in the first example, right here, we have two secant lines. Secant, secant. So when you want to find different parts of these secant lines, what's important to know is that you have to multiply still. So the products are still equal. But you have to take the whole thing. You have to take A times C. So the whole thing times little. So kind of like in the last lesson or a couple lessons ago, we did big times baby. I'm going to call this big times little. Or you could say whole times just the outside equals whole, AE, times just the outside. That's one scenario. There's a second scenario when you have one tangent and one secant line. So you have this tangent and this tangent and this secant. What happens in this scenario is you don't have a whole. You can't do whole times outside equals whole times outside because there's not a whole. There's just an outside. So in this example, you would do AB squared is equal to the same thing as whole times just the outside. Okay, so we have two scenarios going on. The first example goes with the second scenario. You have a tangent and a secant. So you take AB, whatever the outside is in this one, and you have to square it and set it equal to the outside, which is 15, times the whole. So you have 15 times the whole thing, which is 15 plus x. So it equals like this. And earlier I was saying whole times outside, which would be 15 plus x times 15. Technically that's the same thing. So if you're asking if the order matters, technically no, because either way you distribute, whether it's in the beginning or in the end, either way you distribute, that's still going to be 225 plus 15x. Okay, so when you simplify right here, subtract 225 and then divide both sides by 15, you're going to get that x is equal to 6.6. Once again, it's important to note, this is 18, this is 15. They're different. You can't just add and assume that x is 3 because that's not correct. Okay, I'm going to use separate sheet of paper again. Number 1 is like scenario 2. Okay, so this is like the scenario we just did. We'll do one of these and then we'll go back to the other scenario we haven't done. So number 1, you have a secant and a tangent, which means we're going to have to do yp squared equals pm times the whole thing pt. So yp was 3.3. So 3.3 squared equals the outside, which is 2.2, times the whole thing, which is, don't just do times x, you have to do the whole thing. 2.2 plus x. Because the whole thing is 2.2 times x. So take your calculator and let's start simplifying. 3.3 squared, that's 10.89. Distribute. Don't assume that that's 4.4 because it's not. It's actually 4.84. And then distribute your 2.2 to your x, 2.2x. Okay, so our goal is to solve for x, so subtract 4.84 from both sides. 6.05 equals 2.2x. Divide both sides by 2.2. This cancels. So you have 6.05 divided by 2.2. So your answer is x equals 2.75. That's what x equals. Okay, let's look at number 2, because we haven't done that scenario yet. That's 2 secant lines. This was a tangent secant. This is 2 secants. So let's look at number 2. So you have to do outside times the whole equals outside times the whole. So when you're setting that up, the outside is 16 times the whole thing, which is 16 plus 26, equals the outside times the whole thing, 18 plus x. Now, once you have it set up, setting it up is the hard part. Solving it, you should be really good at. So combine these first, 16 plus 26. So you have 16 times 42 equals, go ahead and distribute this. I could combine these two first because they don't have any, they're common terms. They don't have any different variables. So that's why I added those, but I have to distribute here. So 18 times 18 is 324, and then 18 times x is 18x. Now I'm going to multiply 16 times 42, which gives you 672. equals 324 plus 18x. Subtract your 324. 348 equals 18x. Divide both sides by 18. And I got 19.3. Repeating, so let's just say it's 19.3. Okay, number 3. Well, first of all, see what's going on. There's two secants. Okay, so we're going to have to do outside times the whole equals outside times the whole. Important thing to note here is that there's dashes, which means if this is 8, so is this. So when you're setting up to solve for x, you're going to have the outside. Be super careful. You're going to want to do 8 times 8, and it's not 8 times 8. The outside is 8, but the whole thing is 8 plus 8. Don't let that mess you up. Outside times the whole equals outside, which is 6, times the whole, which is 6 plus 2x. So I can combine 8 and 8, which makes 16, so 8 times 16 equals, distribute, 6 times 6, 36, 6 times 2, 12x. 8 times 16, 128 equals 36 plus 12x. Okay, subtract your 36. 92 equals 12x. Divide both sides by 12. 7.7. All right, I want to give you, it's going to be a couple of minutes because I want you to try 4, 5, and 6. Okay, make sure you pay attention to what's going on. This one is different than these two. This one you have to square 13. Okay, I'm going to give you a good 5 minutes maybe. Try these 3. All right. So on number 4, 13 squared is equal to the outside times the whole. So 9 and 9 makes 81. 13 squared is 169. 9 times 5 is 45. Subtract your 81, divide by 45, and I got 1.96. Number 5 was outside times the whole, outside times the whole, which is 6 times 6 plus 4x, and 6 times 6 plus x plus 3. You need to combine your 6 and your 3 to make 9. I distributed the 6, got 36x plus 24x. Then I distributed this 6 and got 54 plus 6x. I subtracted both sides by 36, subtracted 6x, got 18x equals 18, and then I got x equals 1. And I even went back and just double checked my answer to make sure if I plug x in, will it work? Number 6 was the same scenario. Outside times the whole, outside times the whole. So 8 times 8 plus 2 equals x times x plus 11. So 8 plus 2 is 10, brings me to 80. X times x is x squared. X times 11 is 11x. You should have gotten right here to this point, and notice I'm going to have to factor. So I subtracted the 80 to get everything equal to 0. Two numbers that multiply to get negative 80, but add to get 11, were 16 and 5, with the 5 being the smallest one, so it's a negative. Set these equal to 0. X becomes negative 16 and 5. We don't want it to be negative, so x equals 5 was our only solution. All right, so those are our notes. I do want to give you some practice questions on page 9. So there's 9 practice problems. Let's do the odds. And so I want you to do the odds. I'm going to give you the answers. That way you can check yourself. Okay? So if you want to write these down, I'm going to give you the answers to the odds. Number 1 should be 14. 3 should be 10. 5 should be 3. 7 should be 12. 9 should be 8. So those are the answers: 14, 10, 3, 12, and 8. Please make sure to have at least attempted these. You should be able to get you have the answers. So you should be able to figure out how to get to the right answers. But when I get back tomorrow, we will talk more about this lesson. I know it was kind of a hard one compared to the others in this chapter, but I have faith that you will push through and persevere. So I will take questions tomorrow. Complete these 5. I want to see that you attempted them and actually set them up and solved the algebra. And then I'll answer more questions tomorrow.